When we're looking at a quadratic function and trying to find the vertex, again our vertex is the point at which we originate from, and it's either going to be concave up or it's either going to open up or it's going to open down. We can take a function, and by this process, we'll show a couple of different examples, but by this process we'll be able to find our vertex, which is an important part. It's that HK. So the first thing that we need to remember is that the standard form of a function that is quadratic is f of x is equal to the quantity a times x minus h, quantity squared, plus k. This is where h and k, again, is our vertex, or the turning point of the graph. A just determines whether it's opening up or down, if it's positive or negative, respectively, and whether it has a vertical stretch or a vertical shrink, as compared to the original graph. So let's take our example function. We've got f of x is equal to 4x squared plus 16x minus 9. In a situation where we have both an x squared term and an x term, we're going to use complete the square technique to find our vertex and get it into a form that looks very similar to our top here. So first thing we do is we're going to isolate our x squared term and our x term. We're going to kick more or less the 9 off to the side. In the next step, we take and rewrite the 4x squared plus 16 times x, and then we're going to leave ourselves some space for the complete the square and subtract 9 at the end. Now, the complete the square technique only works when we have a regular x squared, so we've got to pull this 4 out of both of our terms before we do so. So, pulling out the 4, I get 4 times the quantity x squared plus 4 times x. Close this quantity out. Minus 9. Now, I can complete the square, which is where we take our middle term, divide it by 2, and then square that. 4 divided by 2 is 2. 2 squared is 4. So what we're going to do is we're going to add 4. And because we can't do just one thing we can't just add something to a side. We would need to add it to the other side or subtract it from the same side. I know this seems repetitive, but this now allows for us to have this nice binomial, which will be x plus 2 quantity squared. So, continuing. Right now we need to get rid of this negative 4. But again, this whole quantity is times a positive 4. So when we separate it, we're going to have 4 times, and I'm going to simplify this quantity here into x plus 2 quantity squared minus, it's 4 times this 4 because it was in our parentheses here. So minus 16 minus 9 more, or minus 25. Comes from that combination of the 16 and the 9. Okay? And at this point, if we look from here and compare it to our top standard form, we now have f of x being equal to 4, which is our a value, so we know it's going to open up, times the quantity x minus h, or, well, now it's plus 2, so that's going to be actually minus a negative 2. Okay, minus a negative 2, plus k, well, right now we've got a minus 25, so if we were to make that a plus k value is going to be a negative 25. Our center, or our vertex, is located at the xy point of negative 2, negative 25. In our second example, again, we're finding the vertex, and we're going to use our standard form, because again, in the standard form, when we've got it there, HK is the vertex that we're looking for. So, our second example problem here, we have f of x is equal to x squared minus 2x plus 1. Okay? So here, what we have is x squared minus 2x plus 1. Now, in this case, we have an x squared and an x term. So what we could do is the complete the square technique. Or, if you've already seen it, maybe you have x squared minus 2x plus 1. We know that this is an x minus 1 binomial. If you don't recognize it, it's okay to go through with the complete the square technique. I'm going to do that now. Okay? We have a coefficient of 1. So, when I throw out my parentheses, I don't have to do the step where I pull out my coefficient, because the coefficient is 1 already. So I'm going to have x squared minus 2 times x, give myself some space, and add 1 at the end. At this point, I'm doing the complete the square. I take 2 and I divide it by 2, giving me 1. 1 squared is 1. So I'm going to add 1 and subtract 1 from this quantity. Now we know for sure that this is the binomial x minus 1 quantity squared. We now have this 1 outside of the parentheses. Take it times our coefficient, which is a 1. 1 times a negative 1 is a negative 1 plus 1, which gives me x minus 1 quantity squared plus 0. In this case, now that we have it in the same form as our standard, a is equal to 1. So it's going to look very similar to the y is equal to x squared graph. We've got x minus h will be 1. So our vertex x value will be 1 plus k is 0. And our vertex is at 1, 0. In our last example today, you might find yourself looking at a function like this. F of x is equal to x squared plus 3. Well, from our previous chapter, we know that the plus 3, when it's not associated with the x, is a vertical shift of a positive 3 units. But trying to find ourselves in this form here, let's go through it. I'm going to isolate my x terms. Okay. And right now I have the quantity x minus some quantity, and it's going to be squared. It's going to give me x squared. That's x minus 0 quantity squared. Okay. X squared is x squared. Minus 0 squared, well, 0 squared is 0. So x squared minus 0, still x squared. And now we have a plus 3 at the end. Our a value is 1, and so we have a center, or a vertex of this, at 0, plus 3, plus k, 0, 3 is our vertex.